So today we'll extend yesterday's conversation about imaginary numbers into complex numbers. All numbers fall into a very broad category known as complex numbers. Complex numbers can always be thought of as a combination of a real number with an imaginary number and will have the form a plus bi, where a and b are real numbers. We say that a is the real part of the number and bi is the imaginary part. These two parts, the real and imaginary, cannot be combined. Like real numbers, complex numbers may be added and subtracted. The key to these operations is that the real components can combine with the real components and the imaginary can combine with the imaginary. Let's try some. So in exercise 1, we'll find each of the following sums and differences. So again, just like in our real number system, we combine like terms. So here we're going to combine -2 and 6 and get positive 4, since we're adding, and then we'll add 7i plus 2i and get 9i. That imaginary unit behaves like an x or a y or any other variable. Just always remember that it's not a variable, it's the square root of -1. Let's do a subtraction together, and I'll leave the other two for you to try on your own. So if we skip to part C together, we're subtracting. Keep in mind that's subtracting everything. You may want to rewrite these, switching the signs. So I'm going to rewrite positive 2 as -2 and -7i as positive 7i so that I don't forget to do that. Then again, I combine my like terms. 5 minus 2 is 3. 3i plus 7i is positive 10i. Try B and D on your own. You can also try exercise 2 on your own. It's just a multiple choice with sum. Adding and subtracting complex numbers is a straightforward process because it's similar to combining algebraic expressions that have like terms. The complex numbers are said to be closed under addition and subtraction. In other words, when you add or subtract two complex numbers, the result is always a complex number. But is multiplication closed? Let's find the following products in number 3 and decide. So here we're multiplying, which means we need to double distribute because we're multiplying binomials. So we'll take our first term and multiply it through the second binomial. 3 times 7 is 21. 3 times 2i is positive 6i. We're done multiplying 3 through, so we'll move over to 5i and multiply it through. 5i times 7 is positive 35i. 5i times 2i is positive 10i squared. We'll now combine like terms. 6i plus 35i is 41i. We'll bring down that 21 out front. And now we need to remember from yesterday that I squared is equal to -1, always. So when we see I squared and we're simplifying an expression, we always want to replace it with -1. So 10 times -1 is -10. And now we can combine these real numbers. 21 minus 10 is 11 plus 41i. Let's do another together. -2 times 3 is -6. -2 times -2i is positive 4i. 6i times 3 is positive 18i. 6i times -2i is -12i squared. Combine your like terms. 4i plus 18i is 22i. Bring down your -6. I squared is -1. -1 times -12 is positive 12. Now combine your real number parts, and you have 6 plus 22i. Try part C on your own. So when we look at the other side to get some more examples, in exercise 4, we're asked to consider the more general product, a plus bi times c plus di, where constants a, b, c, and d are real numbers. So for part A, we'll show that the real component of this product will always be AC minus BD. So in other words, let's just multiply this out. So we have A plus BI times C plus DI. Double distributing just with lots of variables. So A times C is AC. A times DI is ADI. BI times C is BIC, and BI times DI is BDI squared. Yet again, I squared is -1, So b times d times negative 1 is negative bd. That's the end real component. This is the front real component. And there is your AC minus BD. The middle imaginary component could be just about anything. Well, let's go to part B and show that the product of 2 plus 3i, and this should be 4 minus 6i, the whole punched it out, results in a purely real number. So we have 2 plus 3i times 4 minus 6i. Get some practice with your double distributing, pause and come back. So when we multiply part B, we get 26. The reason being that the imaginary component in the middle canceled out. Well, this is a special condition called conjugates. This is something that you'll want to get into your math dictionary as well as your cumulative notes. Conjugates are numbers that, when I multiply them, we get rid of the imaginary unit. We'll also use them later when we want to get rid of square roots. We'll multiply by conjugates. But for now, we're talking about imaginary numbers. So the conjugate of a binomial is exactly the same except the sign on the inside. So, for example, if I have 5 plus 2i, its conjugate is 5 minus 2i. The numbers themselves, 5 and 5, 2i and 2i, are the same, but the signs between them are opposites. And anytime I multiply a complex number and its conjugate, I get a purely real number. Those inside terms cancel out. Double distribute this example and prove that I'm right. So when I multiply the conjugates, 5 plus 2i and 5 minus 2i, I get the purely real number, 29. That works every time, and that will be very handy for us later. Let's look at exercise 5. Here we're asked to determine the result of the calculation below in simplest a plus bi form. So we're just asking you to practice your properties. Here we'll double distribute. We have a binomial times a binomial. And then we'll add to that this monomial times a binomial. So remember your GEMDAS. Multiply these and simplify them. Multiply these and simplify them. And then you add. Try it on your own and check back against my answer. So the result of exercise 5 is negative 29 plus 7i. And in the final exercise of the lesson, we're asked which of the following products would be a purely real number. We do not expect you to multiply all of these out until you get a purely real number. What we expect is for you to understand that anytime you multiply a complex number by its conjugate, you get a real number. So you go through the choices and determine which of the two binomials are conjugates of each other. Remember, a conjugate is when the real numbers are the same, the imaginary numbers are the same, but only the signs inside are different. So choice 3 will result in a purely real number because the two binomials are conjugates of each other. That's it for tonight. Have a good night.